We've been through an example of estimating the volume of a solution based on adding a known mass of a solute and then measuring the resulting change in the concentration. I'd like to go through this example again, but this time I'm going to do it in Microsoft Word so I can show you how to use Microsoft Equation Editor and how to represent mathematics professionally and electronically. So the start of this example is to measure the background specific conductivity. In this case, the specific conductivity is defined by the temperature-corrected conductivity, or what the conductivity would be if the solution were at 25 degrees Celsius. And we're going to get the background before we add any solute. Now there's two ways to add an equation in Microsoft Word. We can either go to the Insert menu and click on this equation symbol here, and then we'll get this little box that says Type Equation here. Or I'm going to hit backspace. I can do the same thing but on a PC by holding down the Alt key and hitting the equals button, or on a Mac you can hold down the Command key and hit an equals button. So again, that's Alt equals or Command equals, and that will start a new equation. Just a quick note from Editor Rob here that I got the key wrong for a Mac. It should be a Control equals sign, not Command equals sign. Also, by default, equations are typically going to be center justified. If I go back to the Home menu, I can use these justification buttons to make it left justified instead. And that's just my personal choice. It doesn't really matter where you want to put it. I just think it looks nicer over here on the left for this particular example. So the first thing we needed to do is measure the background conductivity. I think on the slide I used EC as the variable name, but I typically, when I'm showing math professionally, I like to use single character variable names. Another character that we see a lot for specific conductivity is a sigma. Now how I do a Greek character is to type a backslash, and that's the slash in the upper right, and I just type out the Greek letter that I want. So in this case, it's a lowercase sigma, so I put in a lowercase s, and I type the word sigma. So if I put in a backslash and followed immediately by sigma, and then I hit the space bar, Microsoft Equation Editor should automatically turn that into the Greek letter sigma, lowercase sigma. Then I'm going to want a subscript to characterize what kind of sigma I'm talking about here. So to get a subscript immediately after a variable, if you type the underscore character, that's the character in the upper right above the dash, then you hit the space bar, then it should automatically create a variable with a subscript. And then I can use the back arrow, or I can use my cursor with my mouse to put the cursor inside that subscript area and start typing a subscript. One other way to do this, I'm going to delete this, put in my equation again, whoops, left justify. Another way to do this is with the equation menu. Everything that you can do with hotkeys in Microsoft Equation Editor, you can also do with menus up here. I just like to use the hotkeys because for me, it's way faster. But you see we have this script option here. I can create a variable with a superscript or a subscript by clicking on this menu. And then I have these options. You can see there's the main text with a superscript, there's the main text with a subscript, or both superscripts and subscripts, etc. So in this case, I could also do this by creating this, and now I have this box here where the main characters go. And here again, I could type a backslash sigma. Or, again, with these menus, I could find the sigma character. It's in these, Greek letters are used a lot in math, so you can generally find those in this quick access area for putting in characters. And there's a sigma right here. So I could also put in the sigma that way. So just a couple of different ways to make superscripts and subscripts using the menus. In this case, I want to call this sigma sub SC, which stands for specific conductivity. Remember, in this case, that means the temperature-corrected conductivity. And in this case, it's going to be the background conductivity. So I'm going to put a comma BG in the subscript. Then if I want to move on with the rest of the equation, I just need to get out of the subscript. And for that, I can just hit the right arrow on my keyboard. And I know I'm not in the subscript anymore because it won't be gray. The subscript won't be gray. So I'm outside of the subscript and I'm ready to continue typing this equation. In this case, we're just writing this out to say what is that conductivity that we measured. And if you go back to the slide, you'll see that the background conductivity was 300 microsiemens per centimeter. Microsiemens usually specify with a Greek mu, so again a \mu space, that will create a mu for me, and then a capital S for Siemens. Now notice that by default, Microsoft Equation Editor is going to interpret letters as variables. But in this case, these letters aren't variables, they're units. And they should not be italicized if they are not variables. So if we want to get rid of the italics, a quick way to do that, I'm holding down the Shift key and hitting the left arrow to highlight the text. You can also do that with the mouse, of course. Once I have the text I want to change highlighted, I can hit the Control-I combination. I think that's both on a Mac and a PC. Control-I gets you that toggling between italicized script and non-italicized script. Just another note from Editor Rob here. I got the Mac key wrong again. It should be a Command-I, not a Control-I. So now I have a non-italicized microsiemen. It's always good to separate your units with a space so they're easy to read. And in this case, it's remembering that I'm non-italicized, so it's still non-italicized when I add some more letters here. And now I need a superscript. A superscript you can create quickly by hitting after a variable the up character, or I'm sorry, the upwards caret character, and that's Shift 6 on most keyboards. And then you hit the space bar, and that creates that little box that's in the superscript. I can either arrow or mouse to that little box to type in the contents. In this case, I want microsiemens per centimeter, and I can put in a -1 for that the per centimeter that I need here. And that's it. That's how I can create some professional looking mathematics designating that I've measured a background conductivity and the value of that is 350 microsiemens per centimeter. So our next line here, the next step in this example was to add a known mass of a solute to our unknown volume. So the mass of solute added, we want to specify as, again, some variable equals to some number in units. Well, we've kind of already got the formatting worked out for this right here. So I'm actually going to copy this and paste it into this new line. And I'm just going to change components of it. So instead of the conductivity, we're talking about mass. So I'm going to change this sigma to an m. Again, I just did that by highlighting the character in whatever way you want, either with the shift and arrow keys or with your mouse. And then I need to change this subscript. It's not the specific conductivity anymore. It is the mass of sodium chloride. So instead of this SC comma Bg, I can type in NaCl. So that's the mass of sodium chloride. This number is not going to be 350 for the example in class. It was 1,000 milligrams. So instead of microsiemens per centimeter, this will be just milligrams. So that way I don't have to do all that formatting again because this is already roughly formatted the way I needed it. I just needed to change the content. Now after we add that mass and we make sure it's fully mixed, we can say what is the specific conductivity after adding the solute. And again, I can reuse this because this is going to be a specific conductivity again. So it makes sense for me to reuse this line, copy this, and put this in place because instead of the background conductivity, this is just the conductivity of the water after we've added the tracer. The number is no longer 350, it is 475. And the units are the same for this, right? It's still microsiemens per centimeter, so I don't have to retype any of this. So take advantage of cutting and pasting. You don't have to be retyping all of this stuff all the time. If you get really fast at typing it, sometimes it's faster to type it than it is to copy and paste. But in this case, we can make use of the text that we already have. So now we say, well, we have a conductivity after we added the tracer and we have a conductivity before. We're interested in the change in specific conductivity. Conductivity due to added solute mass. Again, a lot of our line is filled out. All we're going to do here is start adding that delta symbol to our conductivity. So I'm going to reuse this text yet again because the change in conductivity has the same units as the conductivity itself. But now in front of this sigma, I want to put a delta, and I want to put the delta on its own. I don't want it inside the main box for this subscript. I want it before the whole thing, before the subscript. So I'm going to make sure my cursor is there and nothing is grayed out, so I know I'm just adding a new element to this existing equation. And I'm going to put a backslash and a delta with a capital D, because we want a capital Greek delta. And again, if I hit space after I do that, Microsoft Equation Editor should automatically turn that into the Greek letter capital delta. Now the change in conductivity is a different number here, but it's the same units. And the change in conductivity is the difference between 350 and 475, which is an increase of 125 microsiemens per centimeter. So this is taking me a little bit of time while I explain all of this as I do it, but you can see possibly how this can be very fast. Once you get used to these little tricks and keyboard tricks, you can get through this really, really fast, probably fast, just as fast, if not faster than you can write it with a pencil. The next step is to say, well, I need to know that relationship between conductivity and concentration to turn this change in conductivity to a concentration. And for that, I need some sort of conversion factor. So the known change in specific conductivity due to a change in solute concentration, we can write as an approximate equality, as I've been doing in class. And if you remember, the one we're using for salt, NaCl, and relatively low ionic strength water, we're going to say that 2, in this case, microsiemens per centimeter. I don't need to retype that. I can copy that unit from somewhere else. Oops, I wasn't in an equation with the 2. So I'll just use this equation, add a 2 to it, and I'll get rid of my original 2. I want my 2 to be in the equation, not outside of the equation. So now I have 2 microsiemens per centimeter. And then again, I want to make sure that I'm in the equation and not in the superscript. So I need to make sure nothing is grayed out where my cursor is, but I still have the box showing me that I'm in my equation. And now you might wonder, how do I do the approximate equals 2 sign? Well, that's another one of those special character combinations. I put in a backslash and I type in the word approx, A-P-P-R-O-X. If I hit a space bar after doing that, again, Microsoft Equation Editor will automatically insert that symbol in place of the backslash code. So this is the approximately equal to symbol. And in this case, I need to say 2 microsiemens per centimeter corresponds to a 1 milligram per liter. Up there's our italics again. I'm going to hold down Shift, hit the back arrow, and do a Control-I to change that into non-italicized text. And I'm going to put a space and a capital L for liter. No square brackets. This isn't length. It's capital L for liter. Now I need a superscript. So I'm going to put the upwards caret, hit the space bar. That creates that superscript off of L as the main character, as the main script or the main text here. And this is per length, right? Milligrams, I'm sorry, per liter. Now I did it. Per liter here. Milligrams per liter of concentration. So now we've specified that unit factor that we can use to do this conversion. And if it were another solute and another solvent, this might be a different set of numbers. You just have to know what these are for whatever chemical you're dealing with, and it has to be consistent for you to do this as a unit factor conversion. So we can calculate the change in concentration associated with the measured change in conductivity. So we measured a conductivity, and we know through a calibration relationship right here that we can turn that into a concentration. So again, no need to retype things here. We can go back and say, well, our change in concentration is going to start with this conductivity. So I've got 125 microsiemens per centimeter. And I'm going to use the unit factor conversion mindset, keeping in mind that if this is linear and consistent, then I can just treat this like a unit conversion. So to show my unit factor, I'm going to put it, just so it's easier to see, I'm going to put it in parentheses. And if I want to put in a defined set of parentheses in Equation Editor, again, I can select parentheses from the equation menus up here. There's something here called brackets where there's all kinds of different parentheses and brackets you can pick from. Or I can just type them. In this case, I'm going to type an open and closed regular parentheses and hit space. And that'll create a parentheses that the equation editor knows this is math in parentheses. So you'll get this box with a dash line around it. And that is, again, where you fill in any numbers or variables that you want to fill in. In this case, I want a fraction inside this parentheses, something with a numerator and a denominator. A quick way to get a fraction is to hit the / in the lower right of the keyboard and hit space. That will automatically create a two-level fraction where I can arrow over to fill in the numerator or fill in the denominator. And again, you will see up at the top here, there is a fraction option for creating fractions with a menu. This is just a quick way to do it from the keyboard. So in the numerator of this fraction, I know I'm going to need, in the denominator of this fraction, I know I need to get rid of microsiemens per centimeters, right? I want to turn microsiemens per centimeters into milligrams per liter. So if I want to create a fraction that's going to get rid of microsiemens per centimeter, I need microsiemens per centimeter in the denominator. So I'm going to take this part of my equality here, and I'm just going to copy and paste it into my denominator. That way, when I multiply this number times this fraction, I know that this microsiemens per centimeter is going to go away. Just to be clear about that, I can use the strike through font. And I just like to strike through these independently just because I think it looks nicer. There's lots of different ways to highlight this text in terms of double clicking or using your mouse to highlight it, or using your keyboard, whichever way works better for you to highlight. You can highlight before you hit this strikeout. There's probably a hotkey for strike through too. I don't know what that is off the top of my head right now though. So we know we're getting rid of this. What are we turning that into? Well, it's the numerator. This is our numerator. We want to turn those microsiemens per centimeters into milligrams per liters in terms of our units. So that's how this unit factor works out. We can put in our equal sign after our parentheses then, and we can type the answer to this, which is 62.5. Again, we don't have to retype these milligrams per liters unit. We can copy it from the multiple places we have it now, and I can copy and paste it in place here. If we want to be super clear here, we can even say what we're calculating and put our cursor at the beginning of this text and say, well, this is a delta concentration in NaC. Oops, sorry, let me hit the space bar first so I can do a subscript here, NaCl equals. So I just popped in there that what I'm calculating is the change in concentration of sodium chloride associated with this change in the electrical conductivity that we've measured. Finally, we need to come up with the answer. So we're going to have to derive the equation for volume and use it to calculate the volume of water. So in this case, we can use the definition of concentration. We know that a given change in concentration of NaCl, so I'm going to start my equation by copying and pasting that, is going to be approximately, remember this is an approximation based on the fact that the mass has little effect on the overall volume of the solution. So to be fair here, this is an approximation that we're doing. I'm going to start a fraction here. Now, sometimes you have to be careful with fractions because if you have a variable, if I type the variable a and hit slash and create a fraction, it will automatically put that a in the numerator. If I want to be sure that I have a fraction sitting by itself without anything in the numerator, I can type that a and I can hit a space bar, then a slash, and then another space. That will put the a before the fraction instead of putting the a in the numerator. In this case, I don't have a numerator yet, and I want this to be a fraction by itself. because the thing before my cursor here is an operator, it will not put that in a fraction because it doesn't make sense to put an operator in the fraction. At least typically it doesn't. But to be really sure, I could hit a space here, hit slash, hit space again to create my fraction. And then I will know for sure that whatever's before my fraction doesn't automatically end up in the numerator. So now I can type in the fact that I know that a concentration change in sodium chloride is going to be equal to the mass of sodium chloride that I added. So, and I already have that variable up here, so I can go copy it and paste it in here. Is going to be the mass of sodium chloride over the volume of my ending solution. So that's the definition of what concentration is, and we can logically think about that dimensionally, mass per volume as a concentration. But the two things we know here are this mass and this change in concentration. We want to calculate the volume. So if we want to show a derivation, we don't want to put an equal sign here because the derivation we do is not equal to this, but it does arise from this. So there's a couple different symbols we can use here to designate this. We can either use a right arrow, in which case we can hit a backslash, type in right arrow, all one word. That will give us a right arrow. Or maybe another way to put it would be a therefore symbol. That's sometimes used in mathematical proofs to say, well, if this is true, therefore what follows this must be true. And a therefore is this little triangle made with 3 dots. So either one of those, a right arrow or a therefore symbol. What we don't want to put in there is an equal sign because what's on to the right of this is not equals to what is on the left of this. Now, if we want to do this derivation, it's going to be all the same variables, just rearranged. So I can copy and paste this. And I can say, well, I know if I multiply both sides times the volume of the solution, then this will go away from here and will end up here. Because it'll cancel out of the denominator here if I multiply both sides times the volume solution, and it will show up on the numerator on this side. And then if I divide both sides by this term, this delta C NaCl, then I know it'll disappear from this side and it'll show up in the denominator from this side. So that's how I do the algebra that I need to do to rearrange the variables to get the variable that I don't know on the left side of this equation. And then I have the ability to plug and chug my numbers into here. So I know that, and again, I can copy and paste. I can say, well, might as well use the same structure and just substitute what I have from previous variables. So mass of NaCl, I can copy and paste the number in units from here. Oops, sorry, I got too much. Just need the equation, not stuff after it. And I can put that in place of this MnACl. And the delta C NaCl, I've calculated that right here. Then I can convince myself by canceling out my units that these milligrams should cancel out because there's 1 in the numerator, 1 in the denominator. An L to the minus 1 in the denominator becomes just a plain L. So my number for this calculation is 16, and my units is just liter. And again, I can get rid of those italics by highlighting what I want to change and hitting Control-I to toggle. So again, that took me a while to go through in terms of the various different ways to do it and explaining to you how I was doing it as I was typing. But if you get those few basic commands down and you understand them and you learn how to use them, you can really rip this math out very fast. So hopefully that gives you an idea of how to start producing math quickly and professionally. It's really helpful if you use this really clear notation to communicate what you're trying to do mathematically.